ladies, this is lesson 5.1, and it's talking about some of the polygons, interior angles. So in the last chapter, we focused a lot on triangles, but this chapter, we're going to spend more time focusing on different kinds of polygons and just trying to come up with some general rules for polygons as a whole. But you still need to know the properties of the triangle and the sum of the triangle interior angles conjecture. So we're going to start there. So the sum of the interior angles of a triangle, and again, this comes from last lesson, so you should know this already, but it is 180 degrees. So any triangle, the interior angles will add up to 180 degrees. So now let's look at quadrilateral. And these quadrilaterals are all kind of special quadrilaterals, but it'll work with any convex quadrilateral. So anyone that has all diagonals inside quadrilateral. So just looking at these quadrilaterals on your note sheet, take out your protractor and measure each of the angles. You can pause the video while you do that. And then once you measure each angle, each interior angle, then find the sum. So add up all of the measures of the interior angles. So pause the video while you measure those angles. So as you measured each angle, kind of check your work, what I have up here. You should have gotten 90 degrees for all four of the first one. And then you can look at B and look at C, make sure your angles measure up. If your angle measure was off, your sum was probably off. So when you add all of these together, for all the interior angles together for each quadrilateral, for every one, you get 360 degrees. So that's our first conjecture. The quadrilateral sum conjecture says the sum of the measures of the four interior angles, quadrilateral is quad, that's four, interior angles of any quadrilateral is 360 degrees. So we know a triangle has 180, a quadrilateral has 360. Now let's look at pentagons. So again, you do the same thing with your protractor, measure the interior angles of 3 pentagons below. So measure angles, and then find the sum of the interior angles. And please pause the video while you do that. All right, you should have gotten these angle measures if you used your protractor. Give or take a couple of degrees. Sometimes it's kind of hard if it's not a perfect factor of 5. But then when you sum these all up, the first one, they should have added up to 540. For the second one, same thing, 540. And for the third one, again, same thing, 540. So these polygons or these pentagons happen to be symmetrical pentagons, but it doesn't have to be that way. They could be non-symmetric pentagons as well, and you would still get 540 degrees. So the measure of the 5 interior angles of any pentagon is going to be 540 degrees. So let's think about that for a second. So we know triangles are 180 degrees. Quadrilaterals are 360 degrees. Pentagons are 540 degrees. So let's go back to our quadrilaterals for a second. And I'm just going to erase all of my angle measures. You should have those down. And if we know a triangle has 180 degrees, we can use that to find the measure of the interior angles for a quadrilateral. Because if we start at any one vertex, and again, we're just going to do like this vertex, this vertex, this vertex, and we're going to see how many triangles we can draw from a single vertex. Okay, so from this vertex, we can draw one diagonal. That gives us two triangles. Same here, one diagonal, one diagonal. So that is from a single vertex. So we have two triangles in every quadrilateral. If the first triangle has 180 degrees, these add up to 180 degrees, and these add up to 180 degrees. That gives us 180 times 2 for the total degrees for all of the quadrilateral, any quadrilateral. We can do the same thing for pentagons. So again, I'm going to erase all my angle measures. You should already have those down. So if I pick any one vertex and draw diagonals from that single vertex, how many triangles do I make? Three triangles for each of these. So if each triangle is 180 degrees, that's going to give me 180 times 3, which is 540. Same here. So now let's look at this next part. Using a straight edge, we'll draw all diagonals from vertex A. So we're just looking at a single vertex of each of these polygons. So the octagon has 8 sides, decagon has 10 sides, 15gon has 15 sides. So how many diagonals can we draw? So get your straight edge. And actually the question is, how many triangles do we make? So 1, 2, 3, 4, 5, 6 triangles for an octagon. For a decagon, draw all diagonals from a single vertex. One, 2, 3, 4, 5, 6, 7, 8 triangles. And then for the 15gon, again, all diagonals from a single vertex. And at this point, you should kind of already see a pattern. You shouldn't have to draw all of these, but we'll do it anyway, just for fun. Okay, so how many triangles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 triangles. So how many triangles do you think you could draw from a single vertex of an n-gon? Well, what's the pattern? For a quadrilateral, which had 4 sides, we drew 2 triangles. For a pentagon, which has 5 sides, we drew 3. Octagon has 8 sides, we drew 6. Decagon, we drew 8. 15gon, we drew 13. So from an n-gon, we would be able to draw that many triangles. So if there are that many triangles, 6 triangles in an octagon, what's the degree measure for the interior angles of an octagon? It would be 6 times 180. What about for a decagon? 8 triangles, each measuring 180 degrees. And for a 15gon, we had 13 triangles, each measuring 180 degrees. For an n-gon, the sum of the measure of the interior angles of an n-gon is 180 times however many triangles there are, which in an n-gon is n minus 2. So now you can use this formula to figure out the sum of the degrees of interior angles for any polygon. So we did a quadrilateral already, we got 360. We did a pentagon, we got 540. We didn't do a hexagon, but we could use this formula. 180 times 6 sides minus 2 is 180 times 4, which is 720. We can do the same thing for a heptagon, which has 7 sides. 180 which is 900. We did octagon already. And for an n-gon, we use our general formula. 180 degrees for each triangle times however many triangles, which is the number of sides minus 2. So please jot down any questions you have. Your homework is listed on your note sheet. And again, I'm collecting homework daily, so please submit your homework the following class every time. And if you have any questions, please jot those down and we can go over those in class next time I see you. Thank you.